In this video, we're going to be looking at implicit differentiation. And implicit differentiation really deals with the situation of finding the derivative with respect to a variable of an equation. And now this equation might be something along the lines of x squared plus y squared is equal to 1. Now, if you recognize this, x squared plus y squared equals 1, that's a circle with a radius of 1. So if I take and draw that right here, okay, so here's my, and again, the radius is 1 unit here. That means any point on this xy circle, or any point on this circle, with point x, y, when we're taking square x, and then we add the square of y, that's going to equal 1. That's the distance we are right here, okay? And we can talk about the derivative with relation to x. If we wanted to talk about how y is changing as x moves around that circle, this is the process, okay? We're going to take the derivative with respect to x of both of these functions, okay? So d dx of x squared is going to be 2 times x, and that's something that we're very familiar with, okay? So 2 times x, and then plus, now we get to the derivative with respect to x of y squared. Now, before we would treat any type of variable as a constant, making that derivative 0. However, now what we're going to assume is that y is actually some type of a function of x, okay? Y is some type of a function of x, and we're going to differentiate it like it would be. Okay, so it's a differentiable function, and this is a general power rule. So you get 2 times y, from the 2 times y to the first, times the derivative of y with respect to x. Well, that's simply the notation dy over dx. Okay, and this is all equal to the derivative with respect to x of a positive 1, which is simply 0. So what we have right now is 2x plus 2y to the first times dy dx is equal to 0. Again, we're trying to find the change in y, or the derivative of y with respect to x, but right now we've got all of these other things. Okay, what we're going to do from here is isolate our dy dx so that we have it as a function of our other two variables. We're going to isolate this. Okay, so from here, now it's just algebra. Okay, so we're going to subtract 2x from both sides, okay, which leaves us with 2 times y times the derivative of y with respect to x is equal to a negative 2 times x. Okay, and now what we have is 2y times this dy dx and over 2x. So our next by 2y, as here we're left with over dx is set equal to negative 2x divided by 2y. Well, these 2's are going to reduce to 1 apiece, and so that's of x divided by y. So here now, the change in y with respect to x is actually a ratio of the opposite of our x value divided by y. In the next video, we'll take a look at what that means for. So we're talking about implicit differentiation, and we've been talking about the derivative of x squared plus y squared is equal to 1. In the first half of the video, we found dy over dx, or the change in y with respect to x, is equal to the ratio of the opposite of x divided by y. Okay? So what we're going to do is we're just going to evaluate numerically at 2 different points here. We've got point A and we've got point B. Okay? So on point A, when we evaluate numerically with our implicit differentiation, the notation looks something very similar to this. The derivative of y with respect to x, when evaluated at a specific point, is going to need to include all of the different variable values of our actual derivative. In this case, we have both x and y. So here's where x is equal to, and a y is equal to. Okay? These two values are actually the values we'll sub in to this situation here. So let's take it with respect to our first point here, A, which is at positive square roots of 2 divided by 2 for the x, and for the y, positive square roots of 2 divided by 2 as well. Okay? So that means that taking the derivative of this is going to be where x is equal to the square root of 2 over 2, and y is, again, that same value, square root of 2 over 2. So our derivative at this numeric piece here, on this point A of the circle, we can see that this is a negative slope. So our first derivative here, dy dx, better be negative. Okay? So it's going to be the opposite of our x value. Well, that's a negative square root of 2 divided by 2, all divided by, just like we had there, our y value, which is again square root of 2 divided by 2. Okay? So this is just simple substitution. To simplify, what we need to do is take and look at multiplying here by 2 over square roots of 2. Again, if we're dividing by a fraction, we can take the inverse of that fraction. And what we have here is a square roots of 2 in both the numerator and the denominator. Those both reduce to 1. And 2's in both our numerator and denominator. Those are both going to reduce to 1. So what we get is a negative 1 over 1 times 1 over 1, which is equal to a negative 1. So this is our instantaneous change of y with respect to x. It's equal to a negative 1 right there. Okay? Similarly, evaluating at point B. Okay? At point B here, now what we have is square roots of 2 divided by 2 and a negative square root of 2 divided by 2. Again, this is our x and y values. So here, so that was for A, down here for B. The derivative of y with respect to x, when x is equal to the square root of 2 divided by 2, and y is equal to the negative square root of 2 divided by 2. By simple substitution, we're going to get the opposite of x, so that's a negative square root of 2 over 2, divided by a negative square root of 2 divided by 2. Well, this quantity and this quantity is exactly the same, and we've got a negative divided by a negative. That is going to give me a positive 1. So the dy dx at square roots of 2 divided by 2 and negative square roots of 2 divided by 2 on this circle, x squared plus y squared is equal to 1, is equal to 1.